Okay, so like I said, in 8.4, we're just going to do some more with rational functions. So basically, when you have variables and a fraction, that's what we'll be looking at. So the first thing that we're going to see, we're going to be looking at our operations. We're really going to focus on multiplying and dividing today. We'll look at addition and subtraction probably next week. But the key thing when you're doing these problems, and these first few, we're just going to look at just simplifying, but you always, if possible, you always want to simplify your numerator and denominator, because if you can cancel things out, it's always going to make your life easier when you're multiplying or dividing. So we'll see as we get into problems, but like really you always want to start by simplifying your rational function if possible. So one thing you always want to be on the lookout for is if you can pull out a common factor. For example, in this function, I could pull out an x from the top. So I could also do that on the bottom. If I pull out an x, I'd have x squared, basically pulling one of the x's out from the x cubed. So what that lets me do, that lets me cancel this x. So I mean, this would be my simplified form, just x plus 4 over x squared. There's really nothing you can do from there. But we're going to see if you can, like, by simplifying that, it just lets you sometimes have less to deal with, especially if you can pull out like a big factor. It can just sometimes make your life a lot easier. So it'd honestly be very similar for part B. You could pull out an x from the top, and you could pull in an x from the bottom. So you could cancel those out. So I mean, this would simplify to be x minus 5 over 3. So always be on the lookout for GCFs, but sometimes you might even have like trinomials that you can factor, difference of squares. So like all those things we've learned about factoring in the course, like, and just kind of try and keep your eyes peeled, because like if you can simplify, a lot of times it'll save you some work in these problems. So like in example A, you could simplify, like you could factor that to be x minus 2. Like what multiplies to 2 and adds up to -3? Well, x minus 2, x minus 1. And then on the bottom trinomial, what would multiply to -6 and add up to 5? Well, that would be x plus 6, x minus 1. So since you have a common binomial, you could cancel these out. So this would simplify to be x minus 2 over x plus 6, which is a lot simpler, especially if you're multiplying or dividing. Like you'd have less things to multiply by or deal with. It just kind of makes, you'll see like as we get into some of these future problems, like it will definitely make your life easier. So you always want to try and simplify first. That's always going to be like your first. Is there anything I can simplify or cancel out? And we talked about like what this would mean visually. Like if you remember that we'd create a hole, we'd have a vertical asymptote. For right now, we're not really worrying so much about that. We're really just trying to simplify these or get our answers algebraically. We're not like graphing or thinking about those different things that might appear. But I mean, you could apply the ideas we saw in 8.3 to what we're doing here as well, if you wanted to answer those questions. For question B, similar idea. If you simplify the top, it would be x, what multiplies to -12 and adds up to -4? Well, x minus 6, x plus 2. What would the bottom factor into, like that x squared minus 4? Does anyone know in the chat or in here? Like, how would you simplify like x squared minus 4? Like, what would that factor down to? Because it's a, I'm assuming you guys kind of hear, but someone in the class said x plus 2, x minus 2, because it's a difference of squares. So that's definitely like one of those kind of special cases, I guess you want to always be on the lookout for. I mean, but realistic, I mean, you are still just factoring it like a normal trinomial. What would multiply to -4 and add up to 0? Because your x term is really 0x. But by doing that, you see these cancel. So it would just simply be x minus 6 over x minus 2. And that's all they're asking, like in these first two, it just says simplify. So I mean, like that's all we're doing. But like I said, I mean, if I asked you like, hey, what are the vertical asymptotes? What are the holes and stuff? Like, I mean, you could use those concepts we've seen before. So let's get into what we're actually, the focus of 8.4 is really about multiplication and division. And if I'm going too fast, like I said, I will post, like I'll post this right after class in case you need to see something, or just let me know, I can scroll back up. But the first thing you always want to do is simplify and then multiply. I mean, sometimes it's kind of a personal taste, but usually if it's possible to simplify, you always want to do that. So So if you remember, when you have variables like fractions, remember you subtract the powers, or like for just like a simple example before we look at this massive behemoth, but if you had like x to the fifth over x squared, basically you could take away two x's from the top, so that would be 3. So so just kind of, that's kind of the idea when you have like powers on the top and powers on the bottom. The powers on the bottom, basically you can take that many away from the top, and vice versa sometimes, but usually you're going to try and take them from the numerator. So if I was looking at this problem, you could multiply it out, or you could start simplifying. For something like this where you don't have like anything that you need to like factor, I would just maybe multiply it out first, or you could start simplifying. It's kind of a personal taste for an example like A. So if you do want to multiply it out, just remember you just multiply across. So that would be 60 for the constants. If you have 2x's and 3x's, remember you add the powers when you multiply. So that would be 5. For the y's, oops, you have 3 and you have 4, so that would be 7 on the top. Then on the bottom, same idea, multiply your constants. 2 times 18 is 36. You have just the 2x's, so nothing changes there. You have a y squared and a y squared, so that's y to the 4th. And then you can just start simplifying, like 60 over 36, like you could reduce, like both of those have a common factor of 6. So if you divided those by, oh, it'd actually even be bigger than that. Like 60 over 36, if you reduce that, like I guess 12 actually goes into both of those. So on the top, that would be 5 over 3. If you simplify, you could also use a graphing calculator if you do 60 divided by 36, and then under the number menu fraction, you can turn decimals into fractions. But that would simplify the 5 over 3 because 12 goes into both of those. And you could have simplified it in like multiple steps, like keep dividing it by 2. You could have done other ways. But for the x's, we have 5 on top, 2 on the bottom. So basically you would take 2 away from the top. Like remember, you subtract the powers when you divide. For the y's, we have 7 on top, 4 on the bottom. So we'd have 3 left up top. So this would be our answer. Usually you put the number closer to the middle though. That would be our simplified form. You also could have started like simplifying things before if you wanted to, but honestly, for a problem like this where it really doesn't matter too much. But for questions like 4 and 5, where you're gonna have to start foiling, like if I multiply the top here, like without simplifying first, I'm gonna have to FOIL these out. Same here, I'm gonna have to distribute this. It's to your advantage to try and simplify these first, because sometimes you might be able to cancel out some things, so it's just easier to do what you have to do next. So like, for example, this top one, like I'm just going to kind of rewrite my, simplify anything I can. Like the top would be x plus 3, x minus 2. Like that would be like what this factors into. 2x plus 8, I'm going to just factor out my GCF because maybe that will be to my advantage. That would be x plus 4. Down here, I could factor out a 2. I'm just going to keep the x squared how it is. Oh, dang it. Sorry. For this one, we could factor this trinomial. That would be x plus 4, x plus 3. So then you just want to see anything that's like the same on the bottom or the top you can cancel out. So for example, I can cancel out my x plus 3s. I can cancel out my x plus 4s. I can also even cancel out this 2. So honestly, there's really nothing to do. Sometimes you still might have to like multiply or simplify things out, but literally all I would have left on the top is that x minus 2. And then on the bottom, I would really only have the x squared. And there's nothing I can do to simplify there. There's not like a GCF I can pull out. There's really nothing I can do to really simplify that from here. So a lot of times, if you get a lot of things canceled out there, which is awesome, but you might, like, for example, if I had like another group here, I still might have to FOIL or multiply it out and stuff, but and it depends what you're doing. Sometimes you might even just keep it in factored form. So we'll look at some of these so I can kind of show more examples. But that's the idea. So maybe if you guys want to try question B, maybe I'll give you a chance to try some. Just I apologize if I'm like cutting people's train of thoughts off at all. Um, but if you start, oops, what did I do? Oops, pencil. So I'm going to just start factoring like the bottom, like this x squared minus 6x minus 7. What multiplies to negative 7 adds up to negative 6? Well, that would be x minus 7, x plus 1. And I know some people, maybe this is a little bit rusty, but I know we like back in our factoring, like you should have got pretty good at like factoring basic trinomials where you don't have to group or any weird things like that. For this this trinomial here, this would be x minus 7, x minus 3. And like I said, this is a difference of squares. This x squared minus 1 is really x plus 1, x minus 1. Like, because x squared is a perfect square and 1's a perfect square. So sometimes, like, I feel like that might be something we don't realize. So I'm going to just rewrite this instead of writing the whole thing. But this would actually simplify all the way down to x plus 2x plus 1, like 2 parentheses x plus 1, x minus 1. And I'll just write a note here just in case. Like that's why. I don't know if this. But basically, you want to see what cancels out. Your x minus 7s cancel, your x plus 1s cancel. So this would be 2 parentheses x minus 1 parentheses x minus 3 all over 1. So you can even drop the fraction if you want. And if you wanted to, like, honestly, I think it's probably better to keep your answer in this form. But you could, if you wanted to, you could distribute the 2 and then you could FOIL it out if you wanted to get it like in standard form. We'll have to see. I haven't really looked in Delta Math. They might ask that you do that, but to be honest with you, it's nice to keep it written in this form. Because like if I asked you, hey, what are the x-intercepts? What are the y-intercepts? What are the vertical asymptotes? What are the holes? Like it's much easier to find when it's already in this form. So I don't really see a big reason to actually multiply it out unless they're asking you to do it. Like I can't think of where that. I mean, maybe there are advantages of the other form, but off the top of my head, it just seems like it'd be nicer to keep it in this factored form. So if you want to multiply it, I would knock yourself out. But like I said, I would just keep my answer like this. I mean, like I said, you could get rid of the fraction because it's over 1. But if you did FOIL this out, like I said, you don't, like I said, I wouldn't do this, but they asked like you would distribute the 2 just to the first group and then FOIL this out. So that would be 2x squared. You'd have minus 6x minus 2x. That'd be minus 8x plus 6. I mean, like you could write your answer like this, but I think it's nicer to actually do stuff when it's in factored form. So it's like I said, I wouldn't go through all that extra work, but you might have a teacher or they might ask you to write it in that form. So I guess you could just multiply it out like Clarence. But let's look at another one. Enough babbling. So for a problem like C, basically you just want to factor anything down. The troubling thing is this x squared plus 3x plus 9, that doesn't really factor, right? Because nothing multiplies to 9 and adds up to 3. Like that's not going to happen. So with a problem like C, and then there's not a ton we can do, if I'm not mistaken. Am I just overlooking something? Just make sure. But on the bottom, on that, oh, that's a perfect cube. So this is like a throwback. I don't know. I'm assuming you guys probably don't remember the SOAP formula off the top of your head. If you remember the difference of cubes, it's this. It's the same sign. And then it's the opposite. And then it's always positive. Is that right? Same sign, opposite, always positive. Yeah, so this would be the formula. So, oops. So like your A would be X, like the perfect cube. So it'd be X, and then 27 is 3 cubes. So it'd be X minus 3. And then you would have X squared plus X times 3. That would be 3X. Oh, and then plus B squared would be 9. So actually you get the same trinomial from that SOAP formula. I know you probably don't remember that off the top of your head, But we did look at that a little bit. But you would actually see you get the same thing on the top and the bottom. So this would just simplify to x plus 2 over x minus 3. But the nice thing is, like I said, if you can bring back those factoring skills, you'll be able to a lot of times cancel out things. Because quite honestly, if they're giving you rational function problems, a lot of times they're giving you them in a way where things are going to cancel out. Like, don't get me wrong, if you just made up equations off the top of your head, probably not a lot of things they're going to clean up. But like they're kind of given problems that are designed to kind of simplify in some ways based on that. But so yeah, that's a throwback to the, if you remember those SOAP formulas, like the difference of cubes. Like I said, that is not something I would expect you to know off the top of your head, but you might have to kind of like, maybe in a future class, I don't know, maybe that'll be a formula they want you to memorize, or they expect you to kind of be able to pull up like from your database in your brain, I guess. I don't know. But in here, I always give the formula for it. Okay, so that's a little bit of multiplication. So big picture, before we move on to division, basically, if you can simplify before you do anything and then just try and cancel things out, you might have some teachers or some directions might ask you to actually multiply it out to get it in standard form. That means you basically got to FOIL everything out. But for my purposes, honestly, I would just keep it in the factored form, like with your binomials, because if you're actually trying to find specific pieces of information, usually that's the better form, in my opinion, at least. But let's look at division. Division really is the same idea, except when you divide by a fraction, remember you multiply by the reciprocal. Like I know a lot of times we've got used to our calculators. You can just put divided by 1/2 in a calculator. That's no big deal. But if you're doing it by hand, really you'd want to multiply by 2, like 2 over 1. Like when you divide by a fraction, you really could multiply by the reciprocal. So for a question like A, like you could either just rewrite it. So it would really be the first fraction we're not messing with. But basically we would multiply by the other fraction flipped, like, or the reciprocal. And then it would just be like any other multiplication problem we've seen. Like for a problem like this, I would just multiply them out and then simplify. So on top, you'd have 6x squared. You just have 1y, you have 2 z's. On the bottom, you have, I'm going to just kind of get it in the same order. We have a 6. We have 2 x's, we have an x squared, we have 3 y's, and we have 2 z's. And I kind of reordered them just so they kind of line up a little bit better. So the 6's cancel, the x squareds would cancel. This is a case we actually didn't see. The z's are actually going to cancel. So pretty much everything cancels except the y. So we really have y over y to the third. So you could subtract the powers. So remember, that would really be -2. Or basically you would have 2 y's left on the bottom. So basically, if you have more y's on the bottom, you kind of want to take that one away from what's on the bottom in a way, if that makes sense. Or you could subtract and then flip it. So if you basically always want to subtract, like, I don't know if this is great advice, but like anytime you have powers, you always kind of want to subtract from the bigger. So if you have more on the bottom, take the top away from the bottom. Or if you have more on the top, take the bottom away from the top. Oh, and sorry for the people in here. But it would be 1 over y squared. Like I said, if you want to, you could kind of go straight here if you want to skip that middle step, if you kind of see that visually, or just subtract the powers. And then just remember, a negative exponent flips your fraction and then moves it to the bottom with a positive of the power it had. Okay, let's look at this last one. Same idea. If you're dividing by this fraction, you want to first do the reciprocal. So for this one, we can actually do it without kind of rewriting. So it would actually be 1 over this 3x minus 24. But just like with multiplication, and this would turn into a multiplication once you do the reciprocal, we still want to simplify anything to cancel any terms out, because like I said, it's going to definitely make your life easier. So this top trinomial, like what multiplies to 48, adds up to -14. Let's think about that. 12 and 4 doesn't work. Is it 16 and 3, that doesn't work. Is it 7? No, that would be 49. What is it? 2 and 24, 4 and is there anything that multiplies though? What would multiply to 48 and add up to negative 14? It's not 4 and 12. Is it 6 and something? 6 and 8. Thank you. Yeah, I was just having like a brain fart for some reason, but it would be x minus 6, x minus 8. If you were like totally screwed, you could always do like quadratic formula to figure out what the two factors would be. But like I said, most of these problems are like there should be things kind of working in your favor. For this one here, we could factor out from the first one just an x, that would be x minus 6. And then from the second binomial, you could factor out a 3, and that would give you x minus 8. So it actually works out really nice. Like I said, it's not always going to be the case, but like we can cancel out both of our binomials. So remember, if you cancel everything out, there's still like a 1 is a placeholder on the top. And then x times 3 or 3 times x would be 3x. But I mean, if you were like, I don't know, some kind of masochist, I mean, you could just multiply, like you could just like FOIL these out. You would see like you would get a lot like similar things and you could factor it at the end, but that's just going to make your life really hard. Like, I mean, because you're going to get some things with like higher powers. You might get cubic functions. You might get quartic functions like with a fourth power. So always simplify it in advance because like I guess you could do it without simplifying first, but man, it's not, it can get tough. So I want you guys to try before you leave. We'll end it on this question. See if you can do example 6. So just be careful, it's division here. So you really want to multiply by the reciprocal of this middle function. But then see if you can simplify these, see what can cancel out, and then what you would get left with. And like I said, I was not going to assign any Delta math or anything. I want you guys to enjoy your weekend. I won't see you guys in class on Monday. So on Tuesday, maybe we'll have a little assignment, maybe some notes. I don't know. We'll have to see with the 75-minute period. I'm not really looking forward to it. I think it's going to I feel like it's kind of rough that long, but we'll figure something out. So just let me know. You can put your answers in the private chat if you want to give this one a try. If you're in person, I can walk, but just see if you can do a problem. If you can do a problem like 6, I mean, honestly, there's really not anything, at least I would throw at you in this class. I mean, there definitely can be worse problems, things that factor not as nicely or different ways you have to factor, but honestly, if it really gets extremely difficult to factor, to be honest with you, I mean, you'd want to use some kind of computer software. Like you can make problems super harder, but I mean, we live in a world where there's computers that can solve problems like that we do in hand in like 2 seconds. So I mean, at some point, it's like it's not worth it. Sometimes, like it wouldn't be like it would be impractical to teach you how to solve like ridiculous problems because, to be honest, no one would be solving those problems by hand. But you should see a lot of things are going to kind of cancel out. Do be careful. Like if you cancel out one thing from the top and the bottom, you can only use like one at a time. Like, so I'll have to see when I get the final answers. Normally that would be it. Oops, it's two up top. Oh, cancel that. Anyone gets their answer, like I said, if you're in the Zoom, you're welcome to put it in the chat. If you're here, I mean, I can glance. We'll see if we got the same thing. Cancel the x squared. That you can also cancel out, like, you can simplify 2/8. So you couldn't multiply that out, but so really on the top, you can also, like I said, cancel out. You might see that 2 go away. So then the only thing, you don't have to, you FOIL this out. Like, I would keep these like x minus 4 equals 2. You could FOIL it if you want. I would just keep it like it is. And at the bottom, this is you get just, yeah. But good. You look at yeah, sometimes that's where it gets a little bit tricky. What happens if you think about that? Should that still be? So this is. You're not looking cheap, like I said, I'm just like trying to see that. Alright, so okay, so raise your bottom. Let's just kind of start touching the bottom. So on the bottom, you're gonna have 8x squared. And that's the new bottom. What can you factor out of this group here? You can see that x squared and then parentheses x 3 then, right? Can't really do anything with this, but just write it. So 4x minus 1 in parentheses. This. So for these, yeah, I think maybe because you're looking at like the old one, which is easy to do. So maybe just erase this. This one, just to kind of make sure this came from this, which is correct. So then you have this 8x cubed minus 2x squared. What can you factor out of that? X plus 2. But now you're going to put a few things to be able to cross that off. You could, if you want, like see like the x squared, you can cancel out 1. You actually have 2x squared, but you can cancel out 1 both to the bottom. Then you could also, if you want, like I don't know, jump in, you can simplify the 2 and the 8. Divide it both by 2. You got 4 on the bottom, 2 on top to go away. Does that make sense? Like 2/8 is really 1/4. So you can change that to a 4, and that would basically cancel out the 2 on the bottom. I know it's like a lot. So I'm just 4 on the bottom. Like that, when you cross it out, that basically turns into a 1. Like 2/8 really is 1/4. So basically it gets rid of the 2 on the top when you do that. So now you're just going to write what you have left. So on the top, you just have the x minus 4x plus 2. And then on the bottom, we got 4x squared. That 1x squared. And then that is like that would be what else gives you. Like I said, like some people might ask it, like, or sorry, boil this out. But honestly, you're really not going to gain anything for like. It's not like you're going to boil it out and something's really going to cancel out or anything. So. I can't think of a reason other than them just asking you to do that, or if it was like a multiple choice test and they were ready to that for that. To do that. That's, you know, right? Life's okay. Life's okay. It's okay. Oh, I hope I stopped the video. Oh, nope.